Now on the test review, I'm going to go over numbers 3 to 6. So these are also exponential equations. However, we're not able to get a common base with these, so we have to use logarithms to help us solve these. So the first thing that we're going to do in these types of problems, we have to first make sure that our exponential expression is isolated. That means that we need to make sure that our, that means that our term with the exponent has to be by itself, right? So here in number 3, this is the term with the exponent, so we got to make sure that that's by itself. You're going to need extra paper for these problems because there's not enough space, so I went ahead and wrote them over here. And this is number 3, right? So for number 3, we have negative 2 times 6 raised to the power x is equal to negative 14. So what we have to do is we have to get this by itself, and to do that, we have to get rid of this negative 2. So since they are bounded by multiplication, we're going to do the opposite. We're going to divide both sides by negative 2, because then negative 2 divided by negative 2 is just 1, so these cancel out, and we're left with 6 raised to the power 6x is equal to negative 14 divided by negative 2, which is positive 7, right? And now from here, we're going to change this to a logarithm, right? So to change this, because we're solving for x, and we want to use logarithms to help us solve this. So right now we have b raised to the power x is equal to a. That's the form that we have right now, right? This is b, this is x, and this is a, right? But we need to change to log base b of a form is equal to x. This is the form that we need to help us solve this, right? So I'm going to go ahead and change this. So log base b of a is equal to x. If it helps you to label things, please do that. It'll make it easier. So I'm going to replace this b, and I'm going to replace it with 6, right? Because I know that b is 6. So I'm going to write my base is 6. I'm going to change this a, and I know that a is 7, so that's what I'm going to write in its place. And then I'm going to change x with 6x. That's what my x is, right? So now I have log base 6 of 7 is equal to 6x. So now what we have to do is we're going to get a value for this, because this has a value, and we're going to do that using our graphing calculator, right? So if you have a graphing calculator that has a log base function, you're just going to go ahead and type this in, right? I'm going to show you that real quick. So you're going to type in, you're going to go to your graphing calculator. You're going to type in, you're going to go to, just going to go to the normal screen. You're going to click the math button, right? The math button brings up this menu. You're going to scroll down to option A, which says log base, and then a bracket. And you're going to type in log base 6 of 7, right? I think that's what we have. Yep, log base 6 of 7. And you're going to click enter, and you're going to get this value, 1.0860. We round to 4 decimals, so that's where we would round. That's what this value is, right? However, if you do not have that function, if you do not have the log base function, you're going to have to use the change of base formula, right? I'm going to write the change of base over here, log base b of a. When you have log base b of a and you want to use the change of base, you're going to have to you're going to use the common logarithm, which has a base of 10, right? Because all the graphing calculators have that. So you would do log of a over log of b, right? This is b, this is a. So when you change this using the change of base formula, you're going to do log of a, which is 7, over log of b, which is 6. So log of 7 divided by log of 6 is equal to 6x. So again, this is only if you do not have the log base function, right? So this is what we got when we use the log base function. However, let's say that you have a calculator that doesn't have that. You're going to have to use the common logarithm. So that's going to be log of 7 divided by log of 6. And you get the same value, right? So since you get the same value, you get the same value, so we're going to use that. So we get 1.0860 is equal to 6x. So all we did so far was just solve a value for this number, or get a value for that number, right? Now we're solving for x, so to get rid of this 6, I'm going to divide both sides by 6. And you're going to go to your graphing calculator. You can either type it's 1.8 or 1.8086, and you're going to divide that by 6, and you get 0.181. 0.181 is equal to x, right? And if you go back to your test, that is option D. Now, just a quick shortcut to show you guys. If you have it typed up on your graphing calculator like this, all you got to do is you're dividing by 6, so just click the division symbol. A and S means the previous answer, so our previous answer divided by 6. And that's not right. Oh, it's taking the, okay, so this is what you have to do, right? So you're going to take this, right? So you're in this step. Now you just do divided by 6. A and S means the previous answer, and then you get same thing, 0.18100. So now we have this, right? All right, so let's go to number 4. Number 4, we're going to do the exact same thing. I typed it out. I need more space, so number 4 is right here. So the first thing I have to do is I got to get rid of this -6 because I'm isolating my exponential expression. So I'm going to divide both sides by -6. Let's get rid of this right here. I'm going to go to my graphing calculator because -89 divided by -6 is not a whole number. -89 divided by -6 gives us 14.83 repeating. So on this side, we have 19 raised to the power x minus 4 is equal to 14.83 repeating. Right? Since we round to 4 decimals, I'm just going to keep this as 4 decimals. And let me rewrite this 4 to make sure that it looks like a 4. Okay. So now, same thing, we're going to change to exponential form, right? So we have b raised to the power x is equal to a. Or, sorry, we have exponential form, we're changing to logarithm form. So I'm going to label, this is the last one that I will label. So this is b, this is x, and this is a, right? We're in this format, and we're going to this format. So log base b is 19, right? So log base of 19 of a is 14.8333 is equal to x, and x is x minus 4, right? So now from here, we're going to get a value for this. So if you have the log base function, go ahead and do that. If you do not have the log base function, you're going to have to use the change of base formula. So this is the last time that I'm going to label things again. So this is b. This is a. The change of base is log of a over log of b. So this is going to be log of a, which is 14.833, divided by log of b, which is 19, is equal to x minus 4. So we're going to get a value for this or for this, depending on which, depending on if your calculator has the function. So log, if you have the log base function, you're going to click math. Log base 19 of 14.833, and you get this, right? If you don't have the log base function, you're going to have to use a change of base formula, which was log of 14.833 divided by log of 19, and you get the same value. So this is equal to 0.9159. 9159 is equal to x minus 4. Now we're solving for x, so we want to get rid of this. So we're going to add 4 to both sides. You get 4.9159 is equal to x. And you go back to your test. And that is option B, 4.9159. So we're going to go over number 5 now. For number 5, I'm not going to label anything. I'm just going to go straight into the forms, right? So I'm going to minimize this, go to number 5. All right, so first step, isolate my exponential expression. So I'm going to divide both sides by 5. So on the left side, these cancel out. I'm left with 8 raised to the power m plus 10 is equal to, I'm going to go to my calculator, 31 divided by 5 is not a whole number. 31 divided by 5 is 6.2. Is equal to 6.2. I'm going to change it to logarithm form, which is log base b, which is 8, of a, which is 6.2, is equal to m plus 10. Right? So once you learn the exponential and logarithm form, you should be able to go through this. If you didn't know how to do it, pause the video and do it real quick and you'll get this, right? So now we're going to use this. We're going to get a value for this, right? So log base 8. So you're going to click math. Log base 8 of 6.2 is this. If you don't have that function, you're going to change this to log of a, which is 6.2, over log of 8, which is b, is equal to m plus 10. And you're going to type this into your calculator. So log of 6.2, close the parentheses, divided by log of, 8. Close your parentheses, click enter, and you get the same value. So 8.774. Or 0.8774 is equal to m plus 10. Now you're going to subtract 10 from both sides. You're going to need a calculator for this part, right? Cancels out here. So you're going to go back to your calculator, and you can just, if you have it up still, just type in minus 10, because remember, a and s uses your previous answer, minus 10, and you get negative 9.1225. So negative 9.11 or 1225. Negative 9.1225 is equal to m. You're going to go back to your here. Negative 9.1226. And it is because they are rounding. So you see how the fifth digit is a 7, so you round that 5 up to a 6. So the answer to number 5 is C. I'm going to go through number 6 again kind of quickly. You should be able to get through these pretty quickly now once you learn them. So I'm going to go to number 6. I have 2 raised to the power m minus 10 plus 9 is equal to 53. So first thing, I want to get rid of this 9. And this time it's added. So I'm going to subtract 9 from both sides. So now I get 2 raised to the power m minus 10 is equal to, and 53 minus 9 is going to be 44. So now I'm going to change this to logarithm form. Log base b, which is 2, of a, which is 44, is equal to x, which is m minus 10. Right? I'm going to use the change of base formula. Log of a, which is 44, over log of b, which is 2, is equal to m minus 10. For this one, you use whichever method you have. I'm just going to do the change of base because that's the one that mostly everyone's going to be using. So log of 44 divided by log of 2. Click enter, and you get 5.4594. So 5.4594 is equal to m minus 10. So you're going to add 10 to both sides, and you get 15.4594, which if you go back to your test is option A, 15.4594. All right, for number 7 and 8, we're going to have to condense each expression into a single logarithm. So to do this, we're going to have to use our properties of logarithms, right? Whenever you see a plus, that is the product property, right? So that means that you multiply these values together. So it's all pluses, there's nothing else. So this is going to be log base 7 of u times v times w, right? U, v, w. However, they write it in a different manner. They write it as w, v, u, which is the same thing. You know, when you're multiplying, the order does not matter. So u, v, w is the same as w, v, u. So the answer is A. Here on the test review, I did really simple examples, but just make sure to understand the properties of logarithms, because on the test, I'm looking at it right now, with logarithm, or with condensing, you're going to, the first one is just like this, right? So the first one's going to be easy, but then the second one, you're going to have to use the quotient property and the power property, or the exponent property of logarithms. So make sure that you understand how to use those. All right, so for number 8, it's the same thing. It's a really simple one. It's just the product property. There's no exponent property. So you just multiply a, b, and c. So this is going to be log base 3 of a, b, c. However, they chose to, in the answer, to write it as cba, but the answer is a here. All right, so it's going to be your responsibility to look at your notes and understand the exponent and quotient properties when you're condensing. I'm telling you right now, and I told you in class as well, that you're going to have to know that for the test. All right, so for number 9, we're expanding each logarithm. So this is the product property, right? So that means that just like we had over here when we're expanding, it's going to be pluses now instead of times. All right, so this is going to be log base 9 of x. So we're going to take this first, right? So now we're done with that. Plus, now we're going to do log base 9 of y plus log base 9 of y. All right, so we're done with that one. And then plus log base 9 of z squared. Now there's one more thing to condense or to expand, and it is this exponent. So I'm telling you guys, again, you have to know the exponent property of logarithms for this test. So it's really simple when you're expanding. You're going to move it into this spot right here. When you have an exponent on your a value, you're going to move it to the front of that logarithm. Don't move it to the front over here, because it doesn't apply to this logarithm. It applies to this logarithm. So make sure that you move it into the front. So our final answer is going to be log base 9 of x plus log base 9 of y plus 2, right? This 2 moved up here, times log base 9 of z, which is answer D. Now, if you wanted to expand, if you wanted to, like if you got this problem and it told you to condense, first you're going to move this over here, right? So now you got this. And then you're going to multiply all of these together, which is what they have. All right, so now let's go to number 10. All right, so for number 10, we are expanding again. And we're going to be using the quotient property as well as the exponent property here. So first, this exponent applies to everything inside of the parentheses, right? So let's distribute this exponent. So this is going to be log base 7 of, so whenever you have an exponent raised to an exponent, you're going to multiply the exponents together, right? So we have 3 times 2 there. So it's going to be 11 raised to the power 3 times 2, which is 6, over, now this gets multiplied here. The exponent is 1. When you don't see it, it's 1, right? 1 times 2 is 2, so this is going to be 6 squared. All right, so now we can expand using the quotient property. So with the quotient property, when you see this, it's going to be the top number minus the bottom number, right? So this is going to be log base 7 of 11 to the 6th power minus log base 7 of 6 squared. So it's going to be this minus this with the logs included, right? So now we can expand further by moving these exponents to the front of the respective logarithm, right? So this is going to be 6 log base 7 of 11 minus 2 log base 7 of 6, which is answer A. 6 log 7 of 11 minus 2 log base 7 of 6.